This is page 65, well done if you've got this far. And serotonin is a neurotransmitter and it's transported back out of the gap, so back into the presynaptic neuron. So if we were drawing a diagram for this, so presynaptic neuron, postsynaptic neuron, it's our transmitter and it goes back in. That's what it's essentially saying there. How does this cause depolarization on these receptors here on the postsynaptic membrane? So this serotonin will bind to these receptors and open sodium channels, and that will cause a depolarization. So serotonin will bind to receptors on the postsynaptic membrane. This will open sodium channels, so cause a depolarization. And so will perhaps lead to an action potential. Part B. It's important that this neurotransmitter is transported back out, so back into the presynaptic neuron. Why? Well, we need to repolarize this postsynaptic membrane, so back to normal, back to resting potential, and then release the transmitter again for a separate nerve impulse. So the postsynaptic membrane needs to repolarize, so back to resting potential. And for the next impulse we need our transmitter to be released again, but we need to get it back into the presynaptic neuron. So the neurotransmitter needs to be back into the presynaptic neuron so it can be released again. And this helps have separate impulses rather than one big impulse. So this allows separate impulses.